Welcome back. Happy Cinco de Mayo. As I know most of you guys are doing this on the 5th, hopefully. All right, so getting down to it, we've already talked about graphing in two forms. We've talked about graphing in vertex form, and we've talked about graphing in standard form. Now, the good thing is that with anything, you can always rearrange equations. And so if you had been given it to in vertex form, you can always change it back to standard form. If you're given it to you in standard form, you could change it to vertex form. Well, those might be easy or hard to do based on the numbers and based on how good you are with doing things. So we're going to talk about the last form that we've seen, and that's factored form. A and B here are in factored form, where an equation is already factored. Now, what I want to do is find the solutions. And if you remember, when we find the solutions, we just set them equal to 0. So I have x minus 3 and 2x plus 1 equals 0, which means that each individual factor is set to 0. So I have x minus 3 equals 0 and 2x plus 1 equals 0. And then if I continue to solve it, and I add 3, let's say, to both sides here, and here I subtract 1 from both sides, I end up with x equals 3, 2x equals negative 1 divided by 2, so x equals negative 1/2. Now, in a second, we're going to come back to these, but what does the solutions tell us about the equations? Let's look at this next one. We start off with x plus 4 times x plus 9. Again, we want to set the equation equal to 0 instead of y. So we're going to have x plus 4 times x plus 9 equals 0. So then each individual factor is set equal to 0. Then we're going to go ahead and subtract 4 from both sides, subtract 9 from both sides. So we get x equals 0 minus 4 is negative 4, and x equals 0 minus 9 is negative 9. So what do those tell us? Well, what this represents is our x-intercepts. So the reality is that we have our x-intercepts for this equation as 3, 0, and negative 1/2, 0. For this one, we have our x-intercepts as negative 4, 0, and negative 9, 0. Well, how do those x-intercepts help us to be able to graph? Well, that's what we're going to talk about, because you can graph your quadratic directly from factored form if you want to. So let's take a look at this first one. First of all, let's find the solutions. Many of you guys can look at it and look at the solutions. I'm going to do it out just so everybody kind of sees it. For those of you who are having a little trouble still solving, but you set both of them equal to 0, x minus 3 equals 0, x minus 5 equals 0. You add 3 to both sides here, so you get your solutions of x equals 3, and then add 5 to both sides here, so you get another solution as x equals 5. Now again, those solutions are just another name for your x-intercepts, or where your graph crosses the x-axis. So we know from our solutions right here that our graph crosses the x-axis at 3, 0, and 5, 0. So now let's come over to our graph. And so we already know that we have 2 points, 3, 0, and 5, 0. So Now, I want you guys to kind of look at this and remember that our quadratic either looks like this or like this. And the axis of symmetry is always directly in the middle of the graph. So if our 2 points are at 3, 0 and 5, 0 here, then our axis of symmetry is aligned directly in the middle of the two. So you can just kind of do, okay, well, what's the middle of 3 and 5? So you take 3 plus 5 divided by 2, and you get 8 divided by 2, or 4. So your axis of symmetry is at x equals 4. We're going to do a few more, but again, remember that your axis of symmetry is always in between the 2 points, the middle of the 2 points. And so all we did was we took our point at 3, our point at 5, and we found the middle of the 2, which is essentially just the average of the 2 points. Now the other thing is that we know our vertex is on the axis of symmetry. Our vertex is on the axis of symmetry. And so right away, we know for our vertex, our x is going to be 4. We don't know what the y is, but we do know the x is 4. Well, let's figure this out. If we remember, our original equation was y equals x minus 3 times x minus 5. Well, if our x is 4, let's see what happens. So we plug in 4, 4 minus 3, and 4 minus 5. Well, 4 minus 3 is 1. 4 minus 5 is negative 1. So we get y equals negative 1. And we can put it back into our point. So now our vertex is at 4, negative 1. And now we kind of can see what the graph looks like. Because we only have 3 points, but we do have the vertex and where it crosses the x-axis. So you can graph it directly from factored form if you want. In a second, I'm going to show you how you don't have to do that. All right, so factored form. Let's get our solutions first. When we get our solutions, we set it equal to 0. So we have x plus 9 equals 0. We have x plus 5 equals 0. We subtract our 9. So we get x equals negative 9. We subtract our 5. So we get x equals negative 5. Again, that means those are our x-intercepts. So we have an x-intercept at negative 9, 0, and another x-intercept at negative 5, 0. So let's come over here. Let's look at our graph. Negative 9, 0 and negative 5, 0 puts my... Okay. Now, I want to find the middle between those two. Now I can look at it visually if I want. I know it's going to go right here. There's my middle. But sometimes it's not as easy to find. So again, you could just take the average of negative 9 and negative 5, add the two up. Negative 9 plus negative 5 divided by 2. Negative 14 divided by 2, which equals negative 7. So your axis of symmetry is at x equals negative 7. Again, your vertex falls on your axis of symmetry. So right away, we know that our x is negative 7, but we do have to find our y. Well, we just plug it back in here. So we have y equals x plus 9 times x plus 5. That's our original equation, but now we're going to plug in our negative 7 because that's what we want our x to be in this case, because our vertex is on our axis of symmetry, and since we know that x is -7 for our axis of symmetry, we know that our x is going to be -7 for our vertex. So now -7 plus 9, -7 plus 5, -7 plus 9 is 2, -7 plus 5 is -2. So y equals 2 times -2, or -4. So your vertex is at -7, -4. There we go. And now we've got our graph. Hopefully things are starting to become a little bit clearer. Okay, so this is your last one. And I'm going to do it both in factored form like we have been doing, but I'm also going to change it to standard form and show you how to do it there. Okay, so first of all, just looking at it, since I have this negative out front here, I know for a fact that my graph is going to open down. But I don't have to worry about that when I graph it in factored form, because it's going to come out the way it should anyway. So let's go ahead and just kind of work through this. First, let's find my solutions. Now, this doesn't matter because it's not going to be a solution, so I just look at my 2x minus 6 and my x minus 7. So I have 2x minus 6 equals 0. I have x minus 7 equals 0. Now I just go ahead and solve it. Plus 6 here on both sides. 2x equals 6 divided by 2. So I have x equals 3. Add 7 here. And I have x equals 7. So I know my two x-intercepts, my solutions and my x-intercepts. They're two different names for the exact same thing, are 3, 0 and 7, 0. So I come over to my graph. I have the point 3, 0. I have the point, 7, 0. Again, for us, the middle is not that hard to find here for my axis of symmetry. So I know it's at x equals 5 just by visualizing it. But if I wanted to look at my 3 and my 7 and then find the average of the two, 3 plus 7 is 10 over 2, and I get x equals 5 that way as well. Coming back to our equation, if I want now to find my vertex, I have to plug it in. So I'm going to start off with my equation as y equals -1 times 2x minus 6 times x minus 7. Now, let's not forget, I already know my x is 5 for my vertex because the x is the same as the axis of symmetry. So now let's plug it in. And instead of x, I'm going to have 5. So now I have -1 times 2 times 5 minus 6, and then 5 minus 7. So then I have -1 times 2 times 5 is 10 minus 6, which is 4. 5 minus 7, which is -2. So -1 times 4 is -4. -4 times -2 is then y equals 8. So my vertex is at 5, 8. So now I come over here, I go to 5, 8, I graph my point, and now, because of the way it opens up here, I can see that it's going to go down anyway, just from where my vertex is compared to my x-intercepts. Okay, same equation. -1 times 2x minus 6 times x minus 7. But this time, I'm going to go ahead and convert it back to standard form, because say that you just went through all this factored form stuff and you're still going, I still don't get it, Mr. Vassos. Well, okay. So your last resort, rather than graphing in factored form, is just to put it back in standard form and then graph it in standard form, which is what we talked about last week. So the first thing I'm going to do here is put it in standard form. I do that by just multiplying through. So I do 2x times x, which is 2x squared, 2x times negative 7, which is negative 14x, then negative 6 times x, which gives me negative 6x, and negative 6 times negative 7, which gives me positive 42. Now I combine like terms, so I have 2x squared minus 20x plus 42. But now I want to distribute this negative to everything here, to every single term. So I'm going to have y equals negative 2x squared plus 20x minus 42. So now we just go with what we already know. If you remember, the axis of symmetry was negative b over 2a. Well, your a is negative 2, your b is 20, and your c is negative 42. So coming over here, negative b would be negative 20 over 2 times a, which is negative 2. So negative 20 over negative 4, which gets me x equals 5. The same axis of symmetry that I had up here. And then now, if you remember, your vertex is all about just plugging your x back into your equation. So we come over here, our equation is y equals negative 2x squared plus 20x minus 42. So I'm going to plug my 5 back in. So now I have y equals negative 2 5 squared plus 20 times 5 minus 42. We do the 5 squared first. So 5 squared is 25 times negative 2 gives me negative 50 plus 20 times 5 is 100 minus 42. Well, negative 50 plus 100 is positive 50. Positive 50 minus 42 is then 8. So y equals 8, which gives me my vertex at negative 5, 8. Once again, same vertex as I had there. Sorry, should be same vertex. My x is 5, not negative 5. I don't know why I put that there. Anyhow, so now, just like we did before, we come over here, we plot our vertex at 5, 8, which gives it to me right there. But now, because we didn't find the solutions per se, we have to figure out some points. Well, we used our pattern, 1a, 3a, and 5a. Remember, our a is negative 2 for this equation. So we have 1 times negative 2, 3 times negative 2, and 5 times negative 2. So we have negative 2, negative 6, and negative 10. So we come over here, and we do exactly what we did last week. We take one step out, we go down 2. One step out, and we go down 2. Another step out, and we go down 6. So 1, 2, 3, 4, 5, 6. Another step out, and we go down 1, 2, 3, 4, 5, 6. Now, I'm going to pause here. You look where it crosses the x-axis at 3 and at 7. And if you look up here, look at that, crossed at the same place. It crossed at 3 and 7. So you get the same graph no matter how you do it. Our last one was going down 10. If we take one more step out, so 1, 4, 5, 6, 7, 8, 9, 10. What I will tell you is this is going to be just a little more accurate because you have 6 points you're graphing from rather than just your 3. But there's your graph. They look pretty similar in nature. Okay? All right. So, no homework tonight, but tomorrow you'll be practicing graphing in factored form, or if you really want, you can convert it to standard form and then graph in standard form. Have a